To send data across a network, hosts do not just dump raw files onto wires. They wrap data in structural layers. This protective packaging is called encapsulation, and it drives how networks communicate. As data travels down the sending host stack, each layer appends its own control information, called a header. The application layer generates the HTTP payload. The transport layer prepends a TCP header containing port numbers. The network layer adds an IP header with source and destination IP addresses. Finally, the link layer wraps this entire packet inside an Ethernet frame with a MAC header and a trailing CRC check. Encapsulation creates an elegant logical symmetry. Each layer on the sending host acts as if it communicates directly with its peer layer on the receiving host. The transport layer reads only transport headers, ignoring the network details below it. This vertical encapsulation enables horizontal peer-to-peer protocol execution across the internet. When the receiving host gets the frame, it reverses the process, performing decapsulation. It strips away the link frame header, analyzes the IP header at the network layer, decodes the TCP header at the transport layer, and finally delivers the clean, original payload up to the waiting application. Intermediate devices do not decapsulate the entire packet. A layer 2 switch operates only up to the link layer. It strips nothing permanently, it simply inspects the MAC frame header to forward the intact packet, remaining completely blind to IP addresses and payload contents. In contrast, a layer 3 router operates up to the network layer. When a packet arrives, the router decapsulates the incoming link layer frame to read the network layer IP header. It uses this IP header to determine the next hop. Finally, it re-encapsulates the original IP packet inside a brand new frame suited for the next physical link, keeping the transport layer and application data completely untouched.